Okay. We are ready to start our webinar today toward machine learning. My name is Hans-Jørgen Jonsrud, and to kick it off, we have Fawad. So with that, Fawad, please take the scene.
Yeah, hello everyone, and welcome to a monthly webinar. My name is Fawad, and I am the Nordic Solution Architect from TDSNX. Today, we will go into depth of an interesting topic that has a huge amount of attention across organization and society, which keeps on getting more and more attention, especially when we're talking about the ChatGPT and robotics and other different kind of topics. It is a topic of artificial intelligence and machine learning. Today we have a solution architect from AWS, Miguel, uh, who will be explaining how these concepts can be used with Amazon Web Services. How Amazon have been moving in this area with their technology to support companies in these areas, and how they can leverage AI and ML through the AWS cloud platform. As this topic is very vast and can be covered in a single webinar like this, the agenda for today will be to cover some of the high-level AI services in AWS, such as recognizing, extract, and comprehend. And then we will concatenating these services together in order to show a typical intelligent document processing architecture, and then go in more depth of how to take this to the next level by developing machine learning on top of this to make it even more powerful and self-intelligent. Lastly, we will close off with an Q&A where all questions can be answered. I will send in the link to this Q&A. It's a software called Mentimeter. So all these questions will be anonymous, and you will also be able to upvote these questions if there's from other attendees which you might also have the same questions of. Um, so I will just provide the link. Please feel free to ask any questions. There's no stupid questions. Any questions is valid, and again anonymous. So there's no shame. We will go through the questions at the end of the presentation. Without further ado, I will give the word to you, Miguel.
All right, thank you, Fawad, and I'm also sharing the video. Hi, everyone. Thank you for joining this webinar. It's a pleasure for me to do this together with TDC Next. So I prepared the presentation, which I'm about to share with you. So as Fawad already mentioned, my name is Miguel. I work as a solutions architect at AWS based in Finland, and I work mostly with Nordics-based customers. And some of the things we do are, for example, reviewing architectures, helping them adopt the AWS services, and also help them adopt machine learning into their business. Yep. So the agenda, we already briefly mentioned that we will give an overview of the AI ML stack, how we call it on AWS. Like, how can you leverage AI ML on AWS? And then we go through a few of the services that are important in the context of an intelligent document processing system. So we will look at those services. We will have a short demo. And as Fawad mentioned, we will go through a kind of a little bit bigger architecture. How could IDP system look like on AWS? We will also talk a bit more on machine learning development on AWS. So let's just start with an introduction to AI ML. So AI is the broader field of making machines behave in a human-like fashion, make them reason like humans. Machine learning actually is a subset of that. So in machine learning, what you do, instead of coding, of trying to code the logic to make the machine intelligent, what you code is actually the way the machine can learn patterns and ways to behave intelligently. And within machine learning, there is also a subset which has shown promising advances recently, as you all know, which is so-called deep learning or neural networks. So deep learning has become more successful lately because of the abundance of data, but also the availability of processing, more processing power than we had in the past. So it is the most complex type of machine learning um, uh, way of doing machine learning. If we look at popular culture and AI ML on popular culture, right? So not so much on the, of course, business as well, but these are things that everybody has seen. Um, we start from the theoretical foundations with the Turing machine. Alan Turing was a scientist which devised a way how we could evaluate whether a machine is behaving intelligently or not. We then had some early scientific research on perceptrons and neural networks. So these were the foundations for neural networks. However, we didn't really have the the computing power available at the time. So there was a kind of a AI winter for a while until in the 90s you got some again a big event was the IBM beat Kasparov at chess, the Deep Blue system. You then go into, IBM continues to be an early player with Watson winning Jeopardy. But then the event of social networks arise and a lot of data being uploaded and a lot of data being available, and neural networks start to make appearance really into the scene with Google's famous, cat recognition in YouTube videos. Facebook delivered the face recognition for all the images they had stored from users. Uh, as a side note, also Amazon developed Amazon Echo in 2014, which was a big advance also in terms of speech recognition and speech synthesis. So it's kind of a voice assistant for your home. Then you see, DeepMind, which is the Google's kind of AI, winning at Go, which is a more complex game with more kind of possibilities than chess. And lately, you have all seen the, stuff like the GPT-3 and now the ChatGPT. So really big advances in kind of text in large language models and the ability of machines to kind of produce human-like text. And the self-driving as well. Autonomous driving is a big topic these days. You also get this kind of image generation, from text to image and image to image type of systems like DAL-E, Midjourney, Stable Diffusion, and also like music generation systems, and all sorts of new systems are coming up. So it's the field is kind of seeing an explosion now thanks to neural networks in part. And in Amazon, what have we? I mean, we have always been doing machine learning, right? We mentioned Alexa and the Amazon Echo, but it's not only that. So in the website, we provided one of the first recommender systems to improve, users navigating the Amazon web shop be able to find the right items for them. So this is kind of the papers that were written back then are still valid. So they are still used in research. So these are good advances in terms of recommender systems. Then of course you have the warehouses, right? We need to forecast demand for a particular product, to stock the warehouses. We also have robots on those warehouses moving stuff, and they need to navigate the warehouse and move products, find the product and move them to another place. So all this requires a lot of machine learning development. And then here is mentioned also the Prime Air as a drone based delivery system. And also, I don't know if you've heard of Amazon Go, which I'm not showing here, but the kind of contactless shop where you enter the shop, you take products from shelves and you leave the shop, and then you get, there is an application, you get the kind of bill on your mobile phone. And in typical Amazonian fashion, and that's why AWS was kind of founded, the learnings that Amazon got from their business, they made available to others to leverage, the same way as the virtual servers as a service was made available for other businesses. The machine learning learnings have also been made available to others, and there is over 100,000 customers currently using AWS for machine learning. These logos here are just some of the public names, the ones that have gone public with their use of AWS, but there are many more. And I work in Nordics with many customers doing machine learning as well on AWS. What do we see customers do with machine learning, depending on verticals. So you have, of course, in healthcare, life sciences, reducing cost of development new drugs and enabling discovery of those new drugs. You have in industrial manufacturing things like predictive maintenance, where you want to predict when a machine is likely to break and require maintenance. This saves a lot in terms of costs to industrial and manufacturing customers. But also things like anomaly detection, looking at the production line, checking for defects in products. Financial services, you have fraud detection, but also credit reasoning, making credit decisions and things like that based on data about users. On retail, you have personalized recommendations, like we already talked, but also in media and entertainment, if you think of streaming services like Netflix, increasing engagement by personalizing what the users see is a big thing. Let's start from basics. What is a machine learning model and how do you develop one? So in very simple terms, you have data. You always need data to create a new machine learning model. You have an algorithm that works on the data to produce a model. Once you have that model that is trained on a set of data, you can use it to create new predictions, so-called predictions, or sometimes called also inferences, which is basically invoking that model in order to get results based on new data that the model might not have seen before. So one typical way to deploy these machine learning models is behind an API, just because it's very convenient for users that are, that don't have the model locally. They can just invoke it through an API and get the result back. Apologies. And there are many different types of algorithms which handle different types of data. Data can be structured data, like in a relational database or in a tabular, if you think of an Excel sheet, for example. That is structured data. But the biggest amount of data and where the models really need training, time, and power is for unstructured, like video, images, audio, text. So that's all unstructured data. The algorithms can be either supervised or unsupervised. Supervised means that when you feed the data to the algorithm, you also feed labels. So you tell this data, this is the image of a cat, but this is an image of a dog. So you kind of assist the algorithm in learning about what is a cat, what is a dog. But there is also unsupervised learning. In this, you just provide data and you let the algorithm find the patterns. For example, for anomaly detection or for clustering. You don't need to label those data items. So this is the basics. We will use this picture again to understand the different layers of the AI ML stack, as we call it. This is what the AI ML stack looks on AWS. So we have 3 layers. From top to down, you get increasingly in a more complex type of machine learning. And if we start from the top, so we have the AI services. This is you don't require any machine learning knowledge to leverage these services. All you need to do is to invoke them via APIs. So these are all models developed by AWS, continuously trained and improved for customers to leverage for different applications like speech synthesis, chatbots, anomaly detection, fraud detection, personalization of content, forecasting, and so on. So here, all you need to do, you need to be able to call an API, which any developer can do. And with that, they add intelligence to their applications. Then you go into the middle layer. So sometimes you have a use case that is not covered by one of those AI services. Or you have data scientists and they can really improve and tune those models specifically for you. In that case, you want to perform machine learning on the AWS platform. For that, we have the SageMaker suite of services, which help you with all the steps in the usual machine learning workflow of ingesting data, preparing it for machine learning, picking the algorithms, running experiments, visualizing, deploying the models once trained, monitoring those models and monitoring the training, developing pipelines for those models. So how do you kind of deploy them to production without disrupting production, right? So all this is handled by SageMaker. We will have a brief look at that at the end. And then, of course, all these top layers are at, supported by this foundation of all the framework, the infrastructure that AWS provides in terms of, different instance types, different GPU types, specialized hardware for machine learning that AWS develops, and then the support to all common machine learning development frameworks like TensorFlow, PyTorch, MXNet. So these are all baked in. We provide machine images, AMIs. We provide container images that you can leverage to start your machine learning and kind of have the libraries installed, everything ready to use the AWS infrastructure. Let's start with the simplest, the AI services. So here we have the model, right? All that I obscured on the left, it's done by AWS. The data you don't need to, the only data you provide is to invoke the API. So it's your data where you want to get the prediction out of. And also the algorithm and the model training and retraining, it's all handled by AWS. You have an API to invoke the service, that's it. And you can do things with it like text summarization, object detection, image classification, and so on. So let's start with a service called Amazon Recognition. Here, the payload, so when you invoke the recognition APIs, which because there are multiple APIs, you invoke it with an image or a video payload. And depending on the API that you invoke, you will get a response, which can be, for example, objects in that image, if you invoke the object detection API. But it can be content moderation, find if there is like explicit content in an image. Or it can be about looking at faces and comparing faces among your users. If you would, for example, develop an identity verification platform. Or personal protective equipment detection. If you are in a factory floor, you want to check that, through a video stream, if your workers are all working according to security or safety best standards. So all the data you send to this service, it's yours, right? It's not stored by the service. It's just, you just get the reply back with the objects in your image, and the image is discarded just in the API call. Of course, in face collections, if you want to have like an identity verification, then you have your own, you manage your own faces, let's call them face vectors. So it's not actually the face images, but the vectors of those images, the representation of those images in the machine learning space. But that's, again, yours, and you can delete it at any time, and it's managed by you in your AWS account, doesn't leave that account. Some applications of recognition already mentioned workplace safety, identity verification, but also media analysis. You have a large repository of media. You want to find out what is there without going manually through all these different videos and pictures. You can just send that media to recognition and get a report with what content is in those media assets. In industrial and retail, and we will see that a bit later, it can be used for classification of specific parts in a factory floor, damage detection as well, again, like anomaly detection and things like that, because it's a visual, it works with visual images, so you can use it for that as well. Now let's look at another service that also works with images, but here the purpose is to handle printed documents, is to extract digitized documents into text, into readable text. So basically doing OCR, optical character recognition. Now, TextRec goes beyond OCR because it does not only do the traditional OCR, it also finds structure. It finds tables, forms. It can recognize handwriting. It can recognize signatures. It also integrates with human in the loop system. We have the augmented AI service on AWS, which helps you send pieces of data that the algorithm was not very confident about for human review. So basically, with all these algorithms, typically you have a confidence. So you have a prediction, you send your data, you get a prediction, you get a confidence score. So how sure is the algorithm of that prediction? If the algorithm is very sure, you might just want to, leave it. You don't need to do anything. But if it's a low confidence, you might want to send that for human review. Here you can see a sample, and we will look in the demo as well, of a document with some structure. And you get the raw text, you get the geometry information. So where is the word, specific word or line in the document? You get forms. If there are forms detected, you can see here the job fair checkbox was found to be selected. You also have table recognition, so you can extract tables from the documents. Now, TextRect has recently also launched so-called specialized document APIs. So these improve on the accuracy when the document you are handling is of a special kind. So if you are handling receipts or invoices, there is a specialized API that doesn't treat your document as just any document, just extracts text, but already expects it to have a certain structure. So with that invoice API, you get summary field, which is your total invoice amount, the tax amount, the vendor name, and then you get line item. So this is the structure that you get out every time you send it to that API. It improves accuracy because it can find much better. It has been trained on invoices and receipts specifically. The other specialized API is the identity API. Sorry, identity document API, which analyzes your passports, driver license. In this, currently, it's trained on US-based driver's licenses and passports. But for example, for passports, the structure is very similar, and the service is extending the support to other countries as well. Just a second. So again, the structure that you expect is constant. You expect to have first name, passport ID, expiration date, things like that. So that's why if you have a specialized document, it's better to use these APIs. Now let's look at another service in this AI. So we talked about recognition, we talked about TextRect. Now let's talk about Amazon Comprehend. Here, the payload, or what you kind of, when you invoke the model, the Comprehend API, through the Comprehend API, what you send is text. It's not images. So you send just unstructured text, a bunch of text, a text file. And Comprehend will extract key information from that text. It can extract, for example, personally identifiable information. It can recognize that there is a name here, or a date, or a company, or an address, a phone number. It can also extract key phrases. What are the important phrases? If you have a very long document, you want to summarize it or have like an idea of where is the important information. It can also analyze sentiment. So is this document, for example, in product reviews, in a web shop, is this review positive or negative? Another interesting thing it can do is classify documents. Basically, if you have your set of documents that you want to separate between invoices, insurance forms, bills, or whatever types of classes you have, you can train Comprehend to recognize your documents and then classify them accordingly with very few data. You don't need, I think it's about 10 documents per class that you need, ideally a bit more, maybe up to 50. But if you have that, you can ingest it to Comprehend, and then Comprehend can understand based on the text whether your document is of this or that type. Topic modeling is another feature. With topic modeling, you don't need to categorize documents. You just send all your documents and you say that these are to be divided in 5 different topics or 6 different topics. Comprehend will then, based on natural language understanding and the text you send it, divide, cluster those documents and provide a topic, a self kind of. Comprehend will try to kind of find what is the topic of each cluster and give it back to you. And then you can categorize other documents based on this cluster that Comprehend found. It can then also detect language of the document, syntax, like the parts of speech in the text, like is this a noun, is this a verb, things like that, and kind of popular or famous events that might be mentioned in the document. Okay, so it seems we are now in demo time. So I'm going to show you quickly about TextRect and Comprehend. And the good thing about, so I'm going to go to the AWS console. I hope you can see that now. And so the way you find the AI services on AWS, once you are in your account, so you need a credit card, you sign up for AWS, right? you see the screen that I'm seeing. You can go here to machine learning, and it will kind of show you the list of all the kind of machine learning related services that AWS provides. And we're gonna go first to Textract, which I already favorited here, so that I'm able to reach it quickly from the bottom, from the top bar here. And the nice thing with these services is that, of course, you can call them as APIs, but they have in the console, you can also test them. So I can go to analyze document, and in the console, it will actually have some sample documents to show you the different capabilities of Textract. So here you can see a pay stub. So this is a kind of a payment, and we call the Textract API and different API. So we call the raw text API, and we get all the text divided by lines, but you can also divide it by words. So you get every word with, we don't see it here, but every word, every line has a confidence score for the quality of the detection, how confident it is that this is the word. You can then look at forms. Did it extract forms? And you can see it highlighted. So you can see the types of relationships, key value type of relationships it found on the document, and also show you geometry, like what are the coordinates in the image where that piece of information is. You can also extract tables, and you can also do natural language queries. That's a new feature. So you can ask questions that Textract will try to answer based on the text it extracted from your document. So what is the year to today gross pay? It found the value there. And what is the gross pay for this period? Things like that. It can identify signatures. In this case, there was one detected. So there are a bunch of sample documents you can find here to play with in the console, but you can also, of course, upload your own if you are curious to see whether it would work well with the type of document you have. So for example, here I have a handwritten voucher. So here is to show also the ability to detect and parse handwriting. So let's say that I'm going to call all the APIs again. Let's see what it finds. And in the queries, what will I ask? Will I ask like, there is something here, 50% off with SBO cards. So I could ask, how much do I get discount with an SBO card? Let's see if this works. I haven't actually tested this. So this is now calling all these different APIs. So to first detect text, so it's just extracting text, and then extracting forms, extracting tables, running the queries on the text, and detecting signatures. Let's see the result. So I apply this. Takes about 1 to 2 seconds, and you get the, the parse text, and you can see that it's pretty, pretty good even with handwritten. Although here 50% off, it's like 5,070. I guess the percent is really written in a way that the kind of algorithm thought it was like a 7-0, and it's kind of understandable. And of course, the confidence here might be quite low actually, because of the ambiguous nature of these characters here. So let's see the other results. So what in terms of forms we got? Yeah, we got title. The title is riding the rails, right? Let's see if we found the title key here somewhere. Yeah, riding the rails. Well, it actually got also something more from that. So we got all that, also the text after that. So there might be some cleaning to do also to the results. Table, it found the table there. So rows and columns. And the queries, let's see, how much do I get discount with an SBO card? It kind of like, there is no discount mentioned, there is off, right? But it, from natural language understanding, it understood that this is the text I'm interested in. But then it kind of, the OCR kind of detected it as 5,070 discount and not 50% discount. Signatures, it detected no signature. There are no signatures in this document. There are, of course, other documents here that you can check for signatures. Let's see if there is anyone with signatures here. Oh, okay, I'll upload another one that I have. I think this Apollo report. Yeah, this has a signature. So let's just run the signature detection now. If you go to signatures, yes, you get that there is this signature here. You also see the confidence score here for the detection. So it detected 2 signatures. Right. Again, great thing about this is when you detect the geometry in the document, you can also, if there are PIIs that comprehend detects, you can then circle back and kind of like obscure that area in the document if you need to. So let's go now to comprehend. So with comprehend, you start with text, not images. So let's do real-time analysis of text, and you can paste here any text. So I encourage you, if you have an AWS account already, to just try it out and see the results for different types of text. But here is already a sample snippet to show you the different things that will be detected. So entities, it found like there is a person mentioned called Zhang Wei, there is a person called John, there is an organization called any company, there is a quantity, a date, and things like that. It also can find the key phrases. So what are the most important phrases in this document or entities in this document? Detects language, which is in this case pretty easy. English, 98% confidence. PIIs, private information, some credit card numbers there, and some emails that you might want to redact. The sentiment, in this case, it's a neutral with most confidence. So it's just statement of things. There is no like a positive or negative. Or actually, there is positive and negative. It was very comfortable. It was also very expensive. Let's see what targeted sentiment gives us. So targeted sentiment is for each word or a kind of key phrase, it will tell you how does that relate to the overall sentiment of the whole text. So some are positive in green, and some are neutral, and some are negative. Finally, the syntax. This is where you kind of divide the text into parts of speech. So you know all the nouns, how they relate to each other, the punctuation, pronouns, verbs, and things like that. So a lot of information that can be extracted from any text. And of course, I could combine text extraction. At the end, I get a plain text CSV file with all the text that was extracted. I can then call the comprehend API with that text to get more details about what that text contains. Let's go back to the slides. So now I want to talk about intelligent document processing, which we have been kind of talking already. So legacy OCR, it's very manual and time consuming. Most results need to be reviewed by humans, which makes it also slow. So if you apply, you probably have the experience of applying for a loan, and there is some head time. People need to go through all the items, all the documents, and approve them separately. So sometimes that might not be needed. Sometimes automatic extraction can help you get most of the data out and speed up the process. So that's one of the main advantages of IDP. Lowering costs by having less human review and speeding up so improving your user experience by speeding up processes. So we already talked about doing that on AWS. Some of the benefits, go beyond just traditional OCR with more accurate and more like structural type of information extraction. You reduce the total cost and you serve your end customers faster. You can then store the insights that you obtain from your documents directly into databases, downstream systems which need that data to be available. So let's combine the two for so a small part of what an IDP system could contain is document classification. So you might want, before you do any extraction of data, you might want to find out what document are we talking about, right? So we already talked about specialized documents like ID. So if you have a first stage where you just extract text, you don't call the analyze ID API yet, you just extract text and send it to comprehend to classify this document. Is it an identity card or is it a loan application? Based on that, you can then invoke the right API from extract to get, for that specific document, the structure, but also you can enrich it further with comprehend processing of that text, right? Now, when you want to train a classifier on comprehend, you need to provide some samples. I mentioned 10 to 50 of each document type. So it's a supervised type of training, so you need to provide labels. So let's say you have emails, support requests, bills. You need to provide examples of emails, examples of support requests, examples of bills, and in a CSV file with the label at the end of each item of text. You then give it to comprehend to train that for you. And you can then use that to run it against new documents and classify them automatically. So the next thing you do is document enrichment. So once you know the document type, you might want to do multiple things. You might want to extract common entities, like we mentioned, like companies mentioned, people in this document, but you might also want to recognize specific entities that relate to your business. So on the right-hand column here, we have a type of entity called policy ID, which is specific to an insurance handler. So that needs to be trained as well to recognize that 456YQT, it's a policy ID entity. And another thing you can do is create a new version of the original document that is redacted for PII. So once comprehend tells you that these were the PIIs found, you can use the geometric information from textract to kind of obscure those on the original image or PDF and provide that for your, maybe some operators need to review the document, but they don't have rights, or you want to omit the personal information from those documents. This is a way to automate that, so they can have a picture of the document without the PIIs. So the A to I, the kind of human review part, based on confidence level. So before, in legacy systems, almost everything needed to be reviewed. Is this the right document that we are extracting the data from? Is the data well extracted? Did it find all the key items that we want to get from this document? And then after that review, you could add the information to your business systems. Now, the aim is not to completely remove the human from the picture, right? Because many times these documents are sensitive, so they require to have a fallback to, specialized people who are experts who can have a look at what the system produced and correct it if needed. But they will not see 100% of the documents. They will see the fraction of those documents where the confidence score was lower. And as the models improve, the amount of documents that are sent for human review decreases, and your cost of processing those documents decreases as well. Now let's look at a little bit bigger picture. So we talked about document classification and data enrichment. This is the same thing here, but this is shown on the more complete AWS service landscape. So there are more services mentioned here, like for example S3, which is an object storage service by AWS. So you can use it to send all your documents. You can organize it by buckets, by folders or keys inside those buckets, as we call them. And then you can have a event-driven type of architecture where things happening in that bucket, or when new data is uploaded, that triggers Lambda. Lambda is our function as running a function as a service, which basically lets you just create code and run it without needing to think about infrastructure. You create a Lambda function and you plug it into events happening in your S3 bucket where you upload your documents to. That triggers the first textract job to get the text out. Through another Lambda, once that is ready, you trigger comprehend to classify the document, and then you go back to textract and comprehend entity extraction. So you start enriching. So you have this document classification at the top from 1 to 5. Then you have the enriching part, let's say from 7 to 8, and you have the human review part there as well in the number 9 and number 10. So if the confidence is low, the Lambda function will redirect the document that is being stored for a human to review. Finally, it will store the key, the business key information that you need in a backend, in a database. In this case, we chose DynamoDB, which is a simple key value store that runs on AWS. But it could integrate with any backend system where you want to store that document data. There is a link there on the top for the solution and the description of each step here. I didn't talk about, for example, the SNS topic, which alerts people to things happening. Like it could be used to alert human reviewers that there is a new document to be reviewed in the queue, so they need to log into the web UI and do that review there. And you can find it there on that link a bit more, the description of this. And this presentation will be shared, so you will have access to these links there. Some customers that do specifically intelligent document processing on AWS are these. So some of these might be familiar. I chose to highlight two of them. NHS is the National Health Service in UK. They used and they started using it during COVID times to process a huge amount of medical bills and invoices. Over 54 million prescriptions per month, and other healthcare documents are mentioned there as well. So they combine Textract with augmented AI, or A2I service, the human review service, to lower the costs of processing these amounts and lower also and improve the accuracy of processing this amount of paper prescriptions. So these are very publicly stating that Textract and augmented AI help them achieve that. Washington Post is another use case that is public. Washington Post uses Textract to equip journalists with data extraction, quick data extraction from public records, things that need a lot of time to analyze. They run it through Textract to kind of get the key insights into what that document contains, and then focus on the parts of the document that might be newsworthy. Just a quick slide also on pricing. So these AI services are typically pay per request type of service. So you pay each time you invoke. You don't pay if you are not using it. So it's per request. And here are some costs. So you can see that detect document text is the cheapest one. So that's when you just want to extract. It's just want to extract text and geometry. If you want to do queries, extract tables or forms, these are slightly more expensive. But this is the price for 1,000 pages, right? So it's priced per page. And the more you process, the cheaper it gets per page as well. You also have a free tier for these services. So if you have an AWS account and if you don't go beyond 1,000 pages, you are just trying out how does the service look, it won't cost you anything. In Comprehend, it's priced according to number of characters since it's text-based. So it's 1 unit is 100 characters. And you can see that for 100 characters, you pay 0.0001 dollar cent. So if you are processing up to 10 million units, which is, what is that in numbers of characters, 10 times 100. So it's a lot of characters. If you go beyond that, you get even cheaper and cheaper, right? And you also have a free tier. So as we already a little bit shown, sometimes some of these AI services allow you to develop your own custom models, like the Comprehend document classification, or the custom entity recognition. So here, the AI service requires you to provide it with some data, but it manages all the rest for you, the algorithm and so on, and the hosting of the model behind an API. Another service, we mentioned it in Comprehend context. Another service that does this, for example, is the first we mentioned, Amazon Recognition. So let's say you have an image, you want to detect objects, you send it to Recognition. It will provide you, there is a machine part, or there is a plant in this file, or there is a person, but it can't really distinguish things that are domain specific to you. When you need to really distinguish between categories that are in your domain, in your business domain, you can develop a custom model in recognition to teach it with a small amount of samples, teach it to differentiate between, in this case, sweet corn and field corn, or between two different parts of a machine that is specific to your process. This is based, again, on transfer learning. So this is based on the idea that you have a huge model that has been pre-trained on millions of images, and now with just a few images, you can quickly tune it for your use case without having to retrain the whole model. So this is easy to do on the recognition service console as well. Now we go to the part where you don't not only provide data, you also want to develop a new use case, or you want to really, you have a good data scientists in your team which are really good at pushing the boundaries, and you want to, develop your own algorithms or improve on existing algorithms. You can then do machine learning with SageMaker. Some advantages and disadvantages are, of course, you need development experience when you go into that road of developing your own model. You need people who know about machine learning. You need to spend time preparing data, doing some selection of algorithms, and then tuning your models. Then you need, once you train them, you need to deploy them behind an API, ideally, and you need to keep monitoring that model. You also need to scale it up and down when there are more requests from users coming into the model. Lots of people are uploading images to your website, and you need to invoke the model often. So you need to manage that. With AI services, none of this is required, right? It scales up and down. It's monitored, it's retrained for you, and so on. But SageMaker tries to make it really easy for you to do the machine learning. So it tries to remove some of the heavy lifting of the machine learning process. It targets not only data scientists, but also business analysts. We have a low code kind of UI within SageMaker that helps business analysts prepare data and train models to be shared then with data scientists that can take the models and improve on them. It also is targeted at ML ops engineers. These are the people who want to make sure that the best practices are followed when developing your models. You don't have biases in your data. You deploy safely to production. So if you already have a model in production and you want to replace it with a new model, the new model is better and you are not having downtime for your users. So for data scientists, we have SageMaker Studio. This is an integrated development environment that tries to keep you under the same UI for doing all the different types of work that you need to do in machine learning development, from data preparation to deploying your model. So it gives you this it's based on Jupyter Lab, which is an open source project, but it has a lot of integrations to SageMaker. It's a hosted service, hosted development environment that you access from your browser, and you can collaborate and run machine learning experiments together with your team. SageMaker Canvas is targeted at the business analysts, people who are used to data, but they don't really have coding or data science backgrounds. They can quickly get started with Canvas, importing some data, doing some, dropping some columns, doing some feature engineering to the data, transforming text to numbers, and then, choose an algorithm and build a model, get some metrics of that model, and try to improve based on that. This is only for tabular data, so it's only for structured data that Canvas supports. SageMaker Studio, it's for any type of data. All right, let's now talk about two use cases of or public customers of SageMaker. We have Formula One. For those who follow, you probably see, here you see F1 Insights powered by AWS there at the bottom. So all these statistics that appear during the Formula One race, these are powered by AWS and by SageMaker. So these are machine learning models that are trained on the huge amount of data that is generated by these cars and sensors placed in the tracks to predict things like who's gonna be overtaking in how many seconds, is this driver going to be in a position to overtake another driver, and other statistics. So this is it's one of those media use cases where it tries to engage the audience by using machine learning, by keeping you, not only giving you the race view, but also data about the race that is ongoing. Another example of this, of the same thing, is Bundesliga in football, and it's match facts. So match facts is a thing that is overlaid during the match, where you can see, for example, the player that was most pressed by the opponents, or the probability of a goal happening in a certain situation, or what were the events during the game that turned the game's kind of dynamics, that changed the course of the game, things like that. So it's again based on data that is captured from the game, video data, and also player tracking and things like that, and trained on SageMaker to then have these predictions live while the game is running. So this was my last slide. I hope you got something out of this presentation. Here are some links that we will share also when we share the presentation with you. So some reference architectures for identity document, intelligent document processing at the top. So you have different use cases for different types of, insurance processing or loan processing, things like that. There are some different architectures there. AI service demos. If you don't have an AWS account and you want to try out some of these AI services, you can go there. It's for free. If you want to try out SageMaker Studio without having an AWS account as well, you can sign up for SageMaker Studio Lab. It gives you a certain amount of GPU and CPU per month that you can use for training. And there is also some example notebooks, basically machine learning code that you can run through to with documentation to understand what's going on. For those looking for inspiration, how AI can be applied to my business, they can go to AI Use Case Explorer, which tells about different use cases that AI is being applied to and how customers leverage AI. So you might get ideas for customers that are similar to you of how you can use. You have the data that belongs to you. That's really the kind of advantage you have. That is your kind of thing that you can leverage to bring value with machine learning. And that data is owned by you. Thank you for this session, and if you have 1 or 2 minutes, please follow this link and provide some feedback for us to kind of improve. And how did you find the session? Thank you so much. If there are questions, I will take them now.
Thanks, Miguel. I think everything is really clear, because it seems like there's no questions from the audience. So I don't think there's anything.
Right.
Feel free to type in anything in the chat if the link gives any problems. So maybe give it 30 seconds if there's anything. But otherwise, besides that, I don't think there's anything. But
I would like to mention at the end.
Thanks for
Just a second, Fawad. The recording will be placed both on YouTube, and it will be placed on our AWS landing page for the webinars. And start the process by placing an opportunity in the ACE portal on the AWS console. And we will be happy to support you through our Nordic Architect and Center of Excellence and the services we have available, and work together with AWS in order to make some new business happening for you as a partner. And as we could see, it is lots of opportunities for you. Study the links and reach out to us, and we will be happy to support you through our local BDMs and our architects. So with that, thank you to you all for attending.
Thank you very much.
Use it toward your end customers. I think this is good material to be presented directly to some of your exciting end customers in order to get them starting the process toward machine learning and how AWS can support them. So thank you all.
Yeah, thanks for now.
Bye-bye.
Bye-bye.
Bye.